Good day, guys. Hope you guys are doing well. Okay, so our last section of basic numbers and operations before we go on to algebra. This is it here. Okay, so we're going to talk today, starting off with scientific notation. So let's write down how to express this number here, a good sized number, 837,400. We want to express this number in scientific notation. Okay, so you'll see what we're talking about here in just a minute. Okay. Scientific notation is when you have a number times 10 to the fifth, or a number times 10 to the negative 7, whatnot like that. Okay, so looking at this number here, 837,400, would you say this is a big number or a small number? If you say big number, you are correct. So make note to yourself here that this is a big number. This will help us later on. Okay. So step one, in order to figure this out, to write that number in scientific notation, we're going to step one. We're going to put a decimal after the first non-zero digit. Okay, make note of it. After the first non-zero digit. Okay, so in this case it would be 8.3740. Okay, but I'm just going to leave out the 0. Okay, so you ought to end up with 8.374. Okay, so that's step one. Step two, we're going to count the number of times we move the decimal until you get to the original number. Until you get the original number okay, so in this case it's 8.374. Going back to the original number, we're going to move the decimal place 1, 2, 3, 4, 5 times to the right. Okay. So let's make a note of that. 5 times to the right. Is the number of place value that we move the decimal to the right. And going to the right is the positive side. The positive side. Okay, this will help us in just a minute here. So, in conclusion, we can say that in scientific notation, this big number there, 8.374, we're going to multiply by 10 to the 5th power. Okay, so this number, 837,400, is equivalent to 8.374 times 10 to the 5th. And there it is. Okay, let's look at another similar type of question as this one here, okay? So let that sink in for a moment. Let's look at another example. This time, let's go small. Let's say 0.00289. Okay? The question is how to express the number 0.00289 in scientific notation. Okay, so let's break this down for you. Ask yourself, is 0.00289, is this a big number or a small number? If you say small, you are correct. Okay, so this is a small number. Really small number. Okay, so step 1, let's follow the same path. We're going to put a decimal after the first non-zero digit. Okay, so the first non-zero digit would be the 2. So let's put the decimal point after the 2. Like so. So you get 2.89. Okay, that's step 1. Step 2, we're going to count the number of times that you move the decimal until you get to the original number. Here's your original number here. Okay, so 2.89, moving the decimal point to get to the original number, we need to add in a few zeros here. Okay, so we are going to move it 1, 2, 3, and then we're back at square 1. Okay, so we move the decimal point 3 times to the left. Okay, and going to the left, think of your number line. Going to the left would be the negative side. Okay. 3 times to the left, the negative side. Right? On a number line, all your negative numbers are on the left. Okay? So our final answer is going to be 2.89 times 10 to the 3rd. Better yet, negative 3, because we're moving to the left, the negative side. Okay, so this is equivalent to 0.00289. Got it? Let's rock on. Okay. Let's do the opposite of what we've just done. We've expressed a number, a decimal number in scientific notation. So let's work backward. Let's give you a number in scientific form and have you convert it into just a decimal number. Okay. Should be pretty fun here. So let's say how to convert scientific notation to what you call standard form. Okay. So for example, here's a scientific notation number. 2.5 times 10 to the 4th power equals what in standard form? Okay, so let's make a note of some rules to live by here. If the exponent is positive, let's move the decimal to the right. So move your decimal point to the right. Right. Easy way you can remember this is this thing that the positive numbers on the number line are on your right. Okay, so that leads to, if your exponent is negative, you're going to do the opposite. We're going to move the decimal to the left. So if the exponent is negative, move your decimal point to the left. Read this a couple times so that you remember the rule. Okay. So here in this case, you have a positive exponent that says you're going to move the decimal to the right. Okay, so I'm going to write down the original number here, 2.5. And then looking at the exponent here, we're going to move the decimal 4 places to the right. 1, 2, 3, 4. Okay, just going off of this rule here. If the exponent is positive, move the decimal to the right. And here we have a positive exponent, so this number is going to be equal to 25,000. There it is. Okay, piece of cake, right? Let's look at another one. Let's go with 4.16 times 10 to the negative third. What would that equal to? Okay, so ask yourself, is the exponent positive or negative? Negative 3. So our exponent is negative, we're going to move the decimal to the left. So write down 4.16, and then we're going to move the decimal again 3 place, 1, 2, 3. Okay, so we're going to get 0.00416. That's our answer. Okay, before moving on, notice that if you have a positive exponent, you end up with a big number. If you have a negative exponent, we end up with a small number. Okay, so this is another way we can check to make sure that the right answer, or we're heading in the right direction there. I love that. It's so much fun. Now, here's another fun type of question that you might see. Absolute value. Okay. That's where you have like vertical bars surrounding your number. So our task will be to find out how to solve absolute value problems. Absolute value type of problems. This is pretty straightforward compared to some of the other type of questions that we've seen. So let's look at an example here. Let's say -8 inside an absolute value plus -3 inside of absolute value. Okay? So, give you one fact here to go off of. Let's say everything inside of the absolute value become positive. So you can say everything inside the absolute value become positive. Okay, so let's look at an example here. You have -8 inside of the absolute value. Okay, so that turns into 8. And then you have plus -3 inside of an absolute value become +3. So 8 plus 3 gives us 11. Okay. Occasionally you might see a negative sign on the outside of an absolute value like this. Minus -6, for example, equals what? Okay. Now this is trying to throw us off. So let's first write down the negative on the outside. Remember, the rule says everything inside the absolute value become positive. So you have a +10, it stays a +10. Okay. Nothing ever turns negative inside of the absolute value. Okay, negative, or actually let's call it a minus sign. -6 is inside of the absolute value, so it changes into +6. Okay, this is that. Okay, so that minus sign is this minus sign here. Equals, so -10 minus 6. Let's give you a quick number line here, just in case. So if you have 0 here, let's say -10 is right here. Okay. -6, are you going to go to the positive side or the negative side? If you say negative side, you are correct. Okay, so -1, -2, -3, -4, -5, -6. Okay, so this is going to be -16. Okay, so again, -10 minus 6, 1, 2, 3, 4, 5, 6. We end up at -16. That's our answer there. Okay. It's easy to miscount and go off to the right side here. for this example. Okay, let's look at one more. You have negative of negative 15 inside of the absolute value plus, let's say, 7 inside of absolute value. What would you get? Okay, push pause and give this a try. I think you're starting to get a hang of this, right? Everything inside of the absolute value turns positive. Okay, so just going to bring over the negative sign up front. You have negative inside of absolute value, so this would turn into a positive 15. Okay, bring over the plus sign here. 7 inside of absolute value stays positive. Again, nothing ever changes to negative inside these vertical bars. Equals, okay, negative 15 plus 7. If you know the answer, please write it down. Otherwise, let's look at a number line where let's find negative 15. Okay, let's say 0 is like way over there. So plus 7, plus we're always going to move to the positive side, not negative side. Okay, so count over 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Wherever we end up there, it's going to be our answer. Okay, so in this case, if you take your time and count it, right, we'll end up at negative 8. Alright. The good old number line. Okay, since we're on the topic of positive, negative integers, let's continue on with talking about how to add integers. Okay, so write it down, please. Our next question is how to add integers. Integers could be positive or negative numbers. So let's look at addition first. So for example, 7 plus negative 9 in parentheses equals what? Okay. Let's make note of this important fact here. If you ever see positive and negative next to each other, it becomes negative. So it turns into a negative. Okay, so say it to yourself a couple times. Positive and negative becomes negative. Okay, so what I mean is, if you see a plus and a minus sign side by side like this, it changes into a negative. So you can say we have here 7 minus 9. Okay, and 7 minus 9 equals, well, if in doubt, draw out your good old number line. Let's say 7 is right here. Let's say 0 is like here. Okay, minus, we're going to go to the negative side, so count back 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's again count back 1, 2, 3, 4, 5, 6, 7, 8, 9. Wherever you end up here, this is going to be our answer. So 2 units to the left of 0 would be negative 2. Okay, so this is negative 2. 7 minus 9 is negative 2. Got it? Let's look at one more. Oh, actually, until we get a hang of this, let's throw some curveball at you here. Let's say negative 4 plus negative 6 equals what? Okay, again, if you ever see a plus and a minus sign next to each other, it becomes negative. So we have this once again. So I'm going to rewrite it as negative 4 plus and a minus, remember, becomes negative 6. Okay. So negative 4 minus 6. Are you going to get a positive number or a negative number? Well, let's find out. Let's say 0 is here. Negative 4 is right here. Okay. Minus 6, we're going to go to the negative side. So we're going to be moving 6 units to the left. Okay, so let's count it. 1, 2, 3, 4, 5, 6. Count it. 1, 2, 3, 4, 5, 6. Okay, our answer is going to be, count it, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. Okay, so negative 4 minus 6 is negative 10. Okay, so there's two more variations of this type of question. Let's take a look at it. Okay, I just want to cover all the bases here, so that if you ever see like strange looking type of question, you would be able to figure it out. So you might occasionally see negative 5 in parentheses plus 2. Okay. Sometimes these negative sign, positive signs throw us off. But if we can just remember that positive and negative next to each other becomes negative, we are going to be in a good shape. So here you have two signs, but they're not next to each other. Therefore, we're going to just leave things the way they are. Okay, so I'm just going to rewrite it as negative 5 plus 2. Okay. So a good old number line here. Whip it out so that we can make sure that we get the correct answer. Start off at negative 5. So 0 would be like right over there somewhere. Okay? Plus 2. We're going to be counting 2 units to the right. Okay? Remember, positive numbers are on your right. So 1, 2. 1, 2. What would be your answer? If you say negative 3, you are correct. Okay. That's so fun. Okay, let's look at another one here. Let's say negative 8 inside of the parentheses plus 14. You're on a roll. I'm going to let you try to figure this one out. Okay. You have, again, negative and a positive, but are they next to each other? No. So that rule doesn't apply. Okay, we're just going to add this up as we see it, negative 8 plus 14. There's no changing of the sign or anything. So whip out your number line, find negative 8. Okay. So 0 would be like somewhere on the right, right? Okay, plus 14. Since 14 is positive, we're going to be going to our right. So let's count it. If you go back to 0, this is going to be 8th place, right? 1, 2, 3, 4, 5, 6, 7, 8. And then plus 14, so 9, 10, 11, 12, 13, 14. Okay, so again, starting at -8, I'm going to count over 14 units to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, where we end up here is 1, 2, 3, 4, 5, 6. So our answer, -8 plus 14 is equal to +6. Okie dokie. Wherever we see addition, chances are you're going to find subtraction also. So let's ask ourselves how to subtract integers. So again, change our mindset from adding to subtracting. How to subtract integers. Okay. Now I'm going to give you another rule to live by. Negative and negative next to each other become positive. Okay, let's say it to ourselves like a couple times here. Negative and the negative next to each other becomes positive. Okay, so like everything else, sometimes it's best to just look at some examples. So let's say 4 minus a -9 equals what? Okay, so right off the bat here, our rule kicks in. You have negative and a negative like this, side by side, turns into a positive. So we can rewrite this as 4 plus 9. Okay, now, what would you get? Okay, straight up here, 4 plus 9. Get 13, right? 13 is our answer here. Okay. -2 minus a -7 equals what? You know what? Sorry. Let's make this, let's say -2 minus 7. Okay. Boo-boo there. So just simply put -2 minus 7. What would you get? Do you have a double negative side by side? You have two negatives, but they're not side by side. So that rule doesn't apply. Okay? So we're just going to say -2 minus 7. Find it on the number line. Let's say 0 is here, -2 is here, minus, we're going to be moving 7 units to the left. Okay. Again, negative numbers are on your left. So 1, 2, 3, 4, 5, 6, 7. Okay. So this would be -3, -4, -5, -6, -7, -8, -9. Okay, so -2 minus 7 is equal to -9. Okay. Try this one. What's 5 minus 13? Okay, so let's check first to see if there are two negatives next to each other. There's just one negative, so you don't have to worry about that rule there. Okay, so 5 minus 13. A good old number line. Okay, once you've gotten a hang of this, you can get by without having to draw these number lines out all the time, but until then, it's a good practice. So I'm gonna say 0's here, 5 is there. Okay, so starting off at 5, we're going to go, well, minus is to the left side, right? Negative numbers here. So we're going to go 13 units to the left. Okay, so here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so let's count it. 1, 2, 3, 4, 5. Takes us to 0. And here's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. Okay, so this here we end up at negative 8. Okay, so 5 minus 13 is equal to negative 8. There you go. Okay, we're on a roll. Let's keep it going. Okay. Negative 6 minus a negative 6 inside parentheses. Try that. Negative 6 minus negative 6 equals what? Okay. Check to see if that rule applies. Do you have two negatives side by side? Yes, we do. Okay, so let's apply that rule here. So the two negatives becomes positive. Okay, so we'll say negative 6 plus 6 plus 6. Okay. What would you get? So let's say 0 is here, negative 6 is here, plus will be going to the right side. So 6 unit to the right side, 1, 2, 3, 4, 5, 6, right? Count it just to make sure. 3, 4, 5, 6 units to the right takes us to 0. Therefore, negative 6 plus 6 is equivalent to 0. Okay. Negative 3 minus a negative 5. What would you get? Okay. Watch the signs. Negative and a negative next to each other, just like this, becomes positive. So, negative 3 is equal, let's write it as negative 3 plus 5. Okay. Give you a minute to draw a number line and see where our value ends up here. Okay. So start off at negative 3. Let's say it's right here. Say 0 is like right here, right? Plus 5, so we're definitely going to be heading east to the right side. Okay, so let's count it. 5 units to the right. 1, 2, 3, 4, 5. So our answer, negative 3 plus 5, is equivalent to positive 2.